I hope it's okay, you guys, that I'm recording. I should have asked before I hit the record button. Thank you. Thank you. That was the hang loose, Brian.
Chaka, yeah.
Yeah. So Pran is a graduate student in the Earth and Planetary Sciences department, EPS department at UC Santa Cruz. And I invited her. She's used other telescopes before, but I've invited her to see how this works because in December we're trying to get
complete.
We don't have to do anything after this exposure. I assume this is the first of the 5-minute dithers. Oh, there we go. Wow, beautiful image. Phil, this is our cluster, I assume.
Yes, I believe so.
Are we able to zoom in?
Yes.
Because I've set my, there we go. Wow.
I think once we background subtract, a lot of other sources will pop out.
Yeah, this is a cluster of stars. So yeah, there's probably a bright one in the middle. How does histogram equalization look for this one? Ooh, wow. I'm sorry I asked. Wow, that is.
You can see a bunch, but it's not quite the best display.
I guess it is. Yeah, we're picking up all of the detector fixed pattern. Yeah, great idea. So this thing that looks like we're part of a final record. That's the doping pattern of the detector, is it? Of the Mercad? These stripes?
Yeah, some sort of pattern on the detector that has to do with its fabrication. And it tracks out very well.
Yeah, I can see faint stars with. Yeah, I wish there was some middle ground between the histogram equalization and the.
Yeah.
Oh wow. Okay, yeah, you can really see the fainter stars in the lower part of that. Oh, it lets you pan. It says it lets you pan.
Oh, there we go. Yeah, that's what I want to do.
Oh, there we go. Yeah, yeah. Beautiful. Oh, wow. So this is a star cluster in Andromeda. Wow, look at that. Oh, that is beautiful.
Yeah, so we definitely have a bunch of sources here. It's a bit hard to pick out, but
yeah, even that central source, still we know the shape of the PSM. So some of those lumps could be other stars, right?
Yeah, they do. It does look like it's a bunch of stars on top of one another.
Yeah. But these images should be sharper than Hubble images in terms of full width half maximum. If I recall, something like a factor 2 better than Hubble images.
Yeah, because I mean, this is a good example of a.
Oh yeah, yeah, that's a good point. That star looks perfectly round and well behaved. Yeah, yeah. Oh yeah, oh yeah. It has a few lumps. There's a few lumps, but
Yeah, so I think that's the static PSF, but there'll be enough of those that you can,
Yeah, yeah, exactly. We can build a PSF and deconvolve effectively. Wow, that is spectacular. Okay. So every star looks like a club sign in a pack of cards. And it's got a lump on top and 2 lumps on the one, each on the left and right. But our main star cluster doesn't look exactly like that. So it's got other stars there.
Yeah.
So good. Percy, thank you. This recording is working. So.
Sure.
So Pran, you want to say a little bit about how you're planning to connect people from Eastern Europe, if you have a moment?
Yes. Hi, everyone. Again, I am Pambera Viceni. So I'm actually doing master's in planetary science at UC Santa Cruz, but I have been involved with astronomy outreach for the last decade. And I'm originally from Kosovo, where I also run the astronomy outreach program. That is the largest astronomy outreach program in Eastern Europe. Usually we reach like 25,000 people around within a year with our outreach activities. This is very new to me. I mean, joining this, it's really fun to see all of this. And I thought it would be really nice to also let other people know about this, because I never heard of this sessions before that you can actually join and watch you guys conduct real-time astronomy observations. And yeah, I plan to share this with other people, because I just came here tonight to see how this is all about.
Okay.
And I'm hoping there will be more people that will be joining next time I'm back.
Thanks, Fran. That's fantastic.
And I use mainly social media to notify most of the people that follow me and my work. So yeah, I think I would be able to reach more people.
That's wonderful. Jeff, if you have a moment to introduce yourself, we'd love to hear from you. I don't know if Jeff could hear me. Amalia, how about you? How did you find out about us?
Oh, hello. Oh, hi.
Hi.
Hi. So I found out through Ohana Kilo.
Oh, fantastic.
Um,
Okay.
Yeah. So I'm a teacher here in Oahu. I teach 1st through 3rd grade.
Okay.
So you know, our children are very interested about astronomy and space. So it's nice to see the different tools and resources that are available to share with my students.
Oh, this is wonderful. Tonight is perfect for children because we're untwinkling every little star. That's really what we're doing today. We're using something called adaptive optics, which in real time undoes the effect of the twinkling of stars. Due to hot and cold air pockets in the Earth's atmosphere, stars twinkle, and this is built into our nursery rhymes. But we are undoing that nursery rhyme right here. And Phil is an expert on adaptive optics, and we're using it to study families of stars in the Andromeda Galaxy that are for which light has been traveling to us for 2.5 million years. So these images are breathtaking quality compared to everything else we've seen of these star clusters. We've been studying these star clusters with the Hubble telescope, but these images are sharper than Hubble images.
Thank you.
Welcome. And you know Sam then?
Yes, I've met him in a previous thing we've had a few weeks ago now.
Okay. And do you know Heather Kaluna and Mailani Neal? They're the co-leads of Ohana Kilohoku.
Yeah, I remember Alyssa Leilani. I remember we had a group together.
Got you. Heather Kaluna is the CEO of Ohana Kilohoku, and she's a professor at UH Hilo. And but she used to be, many years ago, she was an undergraduate. When she was an undergraduate, she was my student. She came to Santa Cruz to do a research project. So I've known her for a very long time. So there are all these connections. And
yeah, it's great.
well, welcome. And I hope I'll share this recording afterwards. So if there are children, other educators, parents interested, we're going to be offering this 3 more times this year. We have 3 nights in December 2nd, 3rd, and 6th. December 2nd and 3rd are on a different telescope, not Keck. They're on the Lick telescope. December 6th is on the Keck telescope, but a different instrument, not this imaging instrument called NIRC2 that you're seeing on your screen. It'll be on a spectrograph called ESI, where we take spectra of stars. So that'll be it for this year. So December 2nd, 3rd, and 6th. And then soon we should know which nights in 2022 we'll have. And that will be starting not in January, but in February, or earliest February, maybe later. But the semester runs from February 1st to July 31st. And it's called the A semester. The first semester of the year is called the A semester. So 2022A will run from February 1st to July 31st. That schedule will be out soon, in a couple of weeks' time. And the first thing I do when the schedule is out is I let Sam know, so that he can advertise this on the Ohana Kilohoku network. I'll let Brian know, so Monica will know. The Keck schedule and Lick schedules come out slightly apart in time, but we'll soon know how many nights we have. We had 22 such opportunities in the second half of 2021, where tonight is the 19th, and then we have 3 more, 22 such opportunities. So this happens quite frequently, a few times a month. And at least the way things are shaping up, we'll have a very large group joining on the 2nd and 3rd. I think, Pran, you think there'll be a group from Kosovo joining? We think there'll be a group from Turkey, groups from 6 different countries in Africa. 6, like Kenya, Nigeria, South Africa, Tanzania, Zambia, Zimbabwe. And then also a group from Monterrey in Mexico, a bunch of high schools from Monterrey in Mexico. Wow. That's a spectacular stretch, Phil. I could really see the star cluster in detail. So the way these observing runs go,
exposure complete.
You can hear the sound that says exposure complete. So we're taking a sequence of 5-minute exposures. And when we stop the first one, the remaining, we start a sequence of 5, and we just, it does all 5 in turn. Phil, it looks like it's doing a 2 and 2 throw, right? 2 in RA, 2 in DEC from the center. Because it looks like this moved to the lower right corner compared to the central image.
Yeah, that looks right.
So one was plenty, and I shouldn't have suggested 2, but this is fine. 2 is fine. It's not moving it out of the frame or anything.
We haven't lost the cluster. Yeah.
No, we haven't lost the cluster. So this field of view is tiny then. It's 5 by 5 or something like that.
No, it's 10 by 10.
10 by 10. Okay.
Am I zoomed in? Maybe I'm.
No, I think what happened is the central
Okay.
image, the star cluster was not right at the center. I think it was a little lower right of center. I think that's what it is. I think the very first image, the central image, it was not quite at the center. I think it was lower right up. That's what I recall. And so now I think it's, yeah, this must be the 3rd. It's finished the 3rd. It's on the 4th of 5. I'm assuming it does it like dots on the 5 of a die, right? 1 dot in the center and 4 in the 4 corners, I assume, what they did.
Yeah, that's what I've been visualizing. I think that's consistent with what we've seen.
Right. So what it's doing is it's taking 5 different images of the cluster, but because the detector, in this case the digital detector, doesn't have a uniform response. Different pixels have different responses, so it helps to not have the image of interest, which is the star cluster, land on exactly the same pixels every time. It's good to move it around, so then you can. It helps. When we are trying to correct for detector sensitivity effects, it helps to have imaged the same star cluster on different parts of the detector. You can see sort of this shadow in the lower left part. You can see what looks like a line in the lower left, that's some kind of cold finger, I assume, like that line in the left, this line. Oh, you probably can't see my cursor, but anyway, if you have any questions, guys, this is a good time while we are doing this sequence, and then there'll be a flurry of activity and we switch to a different cluster, or we'll switch filters, I guess, and take images in another filter. This is in what filter? Let me see if I can read that here. We are in filters K. So this is 2 microns, 2.2 microns is the wavelength of the light that we are seeing. And we will soon switch to the H filter, 1.6 micron, and take a series of 5 images. Since we have a small group today, let's see, we haven't heard from Jeff. And if not, I see H. Griffin. Would you like to take a moment to introduce yourself, please?
Yeah, hello, I'm Hap Griffin from South Carolina, friend of Vera Hyseni. She sent me the link, so I'm glad to join tonight.
Very nice to meet you. I didn't catch your first name, sorry.
My name is Hap, H-A-P.
Oh, Hap, okay. Fantastic. Are you an astronomer? I see astronomy images behind you.
Yes, I'm an amateur astrophotographer. I've got an observatory here in South Carolina.
Wonderful. Welcome. Welcome to our Shadow the Scientist nights. And Pran, thank you for making this connection. It's wonderful. We'll be doing this often. I think this is going to be a regular feature for us.
Yeah, Pran and I have recently discovered an asteroid, so we've got that under our belt.
This is the one that's named after her? Or a different one?
This is a new one.
It's a new one. Okay. We were thinking of using some of our end of night time in the Lick telescope to take a spectrum of one of these asteroids to see what it looks like under a 3.5 meter telescope.
Yeah, that would be great. The one that we recently discovered is currently at magnitude 25.
Oh, that's different. Yeah. Okay.
Yeah, I've got a 12.5 inch scope, and that's a little bit beyond what I can do.
Well beyond, I would say. Yeah. There's an 18th magnitude asteroid that has Pran's name on it that we were going to try and get a spectrum of.
Yeah, I've gotten a number of images and videos of her asteroid.
Ah, I see. Okay. We were hoping to take a spectrum and see what the albedo of the asteroid is doing.
Right. I've gotten a partial light curve, but not a complete cycle yet.
I see. What is the rotation period of the asteroid?
Right. I've gotten about 2 hours worth. I've gotten about 2 hours worth, and it's not a complete cycle, so it's obviously longer than that.
Got it. So Phil, this is the upper right position of the star cluster. And yeah, it's, I think the central position must not be at the center of the array.
Yeah, I think that's right. So this is our last image it's exposing on, and then we can move to H-band.
That'd be great. Okay. And you switched the filters just by online commands?
Yeah, it's just the text command.
Hey guys, sorry to interrupt. I just noticed that in the FACSUM, the rotator says halted. So wondering if you guys hit anything on the rotator?
No.
No?
I'm not sure.
I do see halted. I do see that.
I mean, we're still showing north, up, east, left on the rows, compass rows. So
Yeah.
I'm not sure what's.
The drive angle is still changing, so that's confusing.
What did you say is changing?
The drive angle
Okay. So
in the FACSUM, yeah.
I see. So that would be consistent with it not being halted, right?
Yeah.
Percy, do you have any thoughts on this?
I was trying to find the mute. Do you have an idea how long it's been like this?
I just noticed it, so yeah, I don't think it's been long. I think it's just when we offset it.
Okay. Well, I guess this is the last exposure on this target.
Should be the last one. Yeah.
But then we're going to change filter and stay on the target. So.
Okay. Okay. That'll give me time to take a look at it.
So I'm sharing my screen, and there's actually 4 windows. This one, which doesn't have that much information on it. Some, but not a lot. This window, which has very little information, and then the 2 that you're seeing from time to time. This one, and this window here. This thing on the upper right is called FACSUM, FACSUM, stands for Facilities Summary. It shows you the direction in which the telescope is pointed, and this is where we notice this is where Tony noticed that the rotator is halted. The rotators think that this is an Altaz telescope, so the sky rotates relative to your detector. So you have to keep rotating the instrument so as not to smear the images. And even though it claims it's halted, I don't think it is actually halted. It's me think. The rotate angle is actually changing in real time. Where did you see that the rotate angle is changing in real time? Oh yeah, I see that, the drive angle.
Yeah.
But I don't think it's changing, but it's bouncing around. Right, okay, so it's meant to hold that steady, right? That's the Sky PA that's trying to hold steady. Or is it meant to be changing gradually? Because it is changing, it's getting smaller. Or getting bigger, I guess. It's a negative quantity that is getting less negative.
I guess you're fixed on a PA. It's doing what it's supposed to be doing. Sky PA is
Yeah.
fixed.
Sky PA is
Yeah.
fixed and the drive PA is changing. That's what we want, right?
Yeah, that's what you want. I'm just trying to figure out if there is something that the AO is doing that might be reflected in the halted and the rotator. Because, you know, when you're doing AO, the AO rotator is working.
So,
I mean,
So
the
that-
last image looked great. So, well, we're still closed loop, so I don't think. Still okay.
it'll be interesting to see this very last image because if there was a problem, it will show up. Hopefully. Phil, you said images 12.
Exposure complete.
There we go. 12 through 16. So it should have finished 16 now.
Okay, so I'm going to change to HBand.
Are you done on? Are you in the middle right now? Sorry. You're not exposing right now, correct?
We are. We were about to change filters and continue exposing. Did you want to check something first?
Yeah, I just found a ticket where a similar problem happened. So Tony, it says Julie fixed the problem by sending a rotator angle from Match.
Really?
Which doesn't really make sense to me, but can you try just setting, I don't know, hitting rotate on Magic? And then, yeah, just try to rotate. And then, could you resend your rotator angle from on your side, Philip?
Yeah, give me a second. A new NERC2 observer, so I always have to look up the commands.
On the tiptoe?
Yeah.
I just want to.
Actually, just open the loop slowly. And then we can just remove it. Yeah, just open the loop.
So it says AO loops are not open. Unable to.
Yeah.
rotate.
So open both.
Yeah. And then tell me to rotate.
Okay, you're good to rotate. The loops are open.
Okay, here we go. Did that fix it? It says tracking now.
Okay, we're gonna reclose loops. It might be worth it to take just a test image just to make sure, but I think we should be in a good position here.
In fact, everything is green on FACSUM. So tracking, AO control.
Okay, taking a test image.
So this is a 10-second image. Huh?
Exposure
No, just
complete.
one.
1 second image, I see.
More.
And this time the star cluster should be in the center or somewhere.
Should be.
Okay.
No, that may. I was playing around with the.
Stretch.
I do.
I think we barely rotated, so it should be, you know, if you see something in the center that looks about
Yeah.
right.
It's right
There's a
there.
cluster. I
It's
mean,
right there. It's right there. And as we suspected, it's a little bottom of the center of the array. So that's why. Yeah.
a
Okay.
little low. I
Yeah.
think that's because I don't think I quite trust the offset parameters I gave you. That's
Well,
probably all it is.
This looks great. This looks great.
All right, so I'm going to switch to H band, I think. And we are closed loop, right? Yeah, we must be because otherwise.
And it changed to H plus clear in the NERC2 status window. So that's great.
I'll just take an exposure here to confirm we're still seeing the star.
Okay.
And then change to the long exposure parameters.
Got you. So iTest just does a 1 second exposure or 1.45, whatever.
Exposure complete.
It does, and it doesn't save the image either. So it's just so. you can
Okay, just test it. Okay,
confirm
I
my
see it there.
memories.
It looked like it got a little brighter. This is in the H band.
Yeah. So I'm going to change it back to 60 seconds for a single exposure, co-add 5 of those.
And I don't know if folks can see this in the little window there. Tint is integration time for 60 seconds. Co-add means it adds 5 of these together before reading out. Non-destructive reads. That's why 5. What do you think? 1.5 or 2? 2 was fine.
2 is fine, yeah, unless you cared about some of those surrounding stars.
We don't. No, we don't. Those are good because they produce PSFs for us. But other than that,
yeah. So this gives us plenty of offset between one image and the next for.
yeah, I think so. I think so.
Okay, so I'll stick with 2.
Let's stick with 2. Yes.
All right, here we go.
That's great. So what we ran a sequence, Phil ran a sequence of 5 images. Now we're running another sequence of 5 images. And what has changed is the piece of glass, the filter in front of the camera. So we are letting in light at 1.6 microns now. Before we were admitting light at 2.2 microns. So we've changed filters, and this is a way of measuring colors of stars and temperatures of stars. So this images in the H band, if I remember correctly, should have a sharper diffraction limit than the K band, but will have a lower Strel.
That's right.
Okay. So a smaller fraction of the light will be in the diffraction limited core. The rest will be in like a seeing limited PSF, but the core should be sharper. And I can only see a single star now, but
yeah, well, that was
just
just
1 second. 1 second.
Yeah, this was a short exposure. So that's that center cluster star.
Got it.
Although it's interesting, we don't see it seemed to be several different stars when we got a deeper exposure. I'm not sure. Maybe one of them's a very different color or something.
Exactly. I was going to say it could be, and very often that happens where if it's a bright main sequence star, if the brightest star is a main sequence star, it could be quite blue compared to the red giants.
Oh, yeah. Okay.
Or it could be a blue supergiant or a red supergiant. In this case, the bright star does indeed look blue compared to at least in H minus K, it looks blue. But one of the cool things that you guys just experienced is things don't always go smoothly, right? So we noticed, Tony noticed there was a problem, and it turns out the problem was probably just in the software that was reporting on whether the telescope is properly rotating the image or not, or the instrument is properly rotating the image or not. And it gives you a fault message. It had that message in red. So that's one of the beauties of this thing. This is not rehearsed, so things will go wrong. things will go wrong in spectacular ways sometimes. We've had nights that are completely weathered out because the clouds were in or the fog was in. And what we've had is we've had some kind of backup set of images, so what I usually do, I'll in fact pretend like something like that is happening. And what we do is, assume you can still see my screen, we'll go to one of these, let me see if I can find it easily. I have too many, a few too many tabs open. But let me see if I can find the particular one I'm looking for. No, not that one. One of these has a, there we go. So, you have this image of the Virgo cluster taken with the Canada-Francois telescope. So, I remember one night the weather was, the telescope was shut down because of bad weather. And we just, used this image, zoomed in onto some of our favorite galaxies, talked about them. And, this is an image taken from Mauna Kea. So it's just taken a few years ago. But we talked about what science we're doing with them, what types of galaxies. You could see amazing galaxy collisions, sort of ongoing galaxy collisions. So this is one of the things, this is the only way in which we've been prepared for bad weather contingencies or instrument breakdown contingencies. I remember we had an observing run where the ESI guider failed. So we had to scramble in real time to change our science experiment for that night. And I think this is sort of important because when you do a real experiment, whether you're an investment banker or an astronomer or a biologist, things don't always go according to plan. You have, so we would show pictures like this, talk about these galaxies, what's going on, the sort of physics of what's going on. There's all kinds of spectacular galaxies in this cluster. I can zoom on. So, this is just, Brian and Pran, as we're thinking about expanding it to other groups, and it's just useful we've learned from experience, it's useful to have some kind of contingency data to display if we are not,
Exposure complete.
in cases when we're not able to take data in real time.
Oh, there's definitely other stars there.
Okay, we switch back, sorry. Oh yeah. It has that same sort of shape to it as before.
It does.
I think that's real. That can't be the PSF because I wouldn't expect the H and K band PSFs to be identical. And at least with the current display that you're seeing, this is something I'm running VNC, but I'm running it in view only mode. I'm running it in this mode where I've deliberately turned off my control because otherwise I'd be interfering with Phil's cursor. We'd be fighting over the same cursor on the same machine. So that looks quite interesting. The image looks very interesting. I believe we're seeing the family. That was just a different stretch just now.
Yeah. Just trying to bring out the background. I think went the wrong direction.
Oh yeah, there we go. Okay. What if you lower the top from 10,000 to say 5,000? That saturates the central part, huh? Okay.
Yeah. In
But
fact,
we can
I'm worried that we're taking too long an exposure for this. For K-band, we were definitely under the 10,000 limit, but
Yeah, are we over?
we're over. We're at about 20,000. So
The value, okay, I see 20,000. Is that, where does it go nonlinear or where does it saturate?
somewhere above 10,000 is where it goes nonlinear.
I see.
So
Are there non-destructive reads that it saves at shorter exposures or not?
No. We might want to stop this and shorten the exposure. I'm trying to decide whether to.
Got it.
Well, I mean, most of the frame will be fine,
Yeah,
but maybe before we move on, we should take a few short exposures so that
sure,
we can.
sure. That would be good. We could, let's see, this is what is it? Is the saturation is set by the integration time, or the integration time times the coads?
No, it's the integration time.
I
So
see. So instead of 60, if we just did 5-6 second exposures or something like that, or 10-second exposures, that would be.
yeah, that should be fine. And that shouldn't take too much extra time.
Right, right.
But one of the things we should talk about before this gets too far along is which cluster you want to do next.
Phil, you've got a good sense of which ones have the best guide stars. How far away is this one's guide star from it?
This is about 11 or 12 arc seconds away.
And it's a bright guide star.
It's reasonably bright. It wasn't the brightest, but Sajnik gave us a bunch that were all about similar enough in brightness that I just chose the one that had pretty close.
Okay.
So I would choose another one of those given this.
Yeah, let's do that. Unless Avi or Monica have any preferences there.
Roger, we can go ahead with the whatever Phil has selected.
Okay, sounds good.
With our cross matching.
Sounds good. And just to round out the introductions, Avi is an undergraduate at Haverford College who's been working with Monica and me for a few months now. And I noticed Jody, actually I noticed Preeti before. So Preeti, would you mind introducing yourself? We'd love to hear from you.
Hi, my name is Preeti Stepp. I actually work with Brian. I'm a third-year PhD student at UC Davis.
Oh, fantastic, fantastic. Okay, I'm a fellow UC person.
Which UC?
Santa Cruz, the best. No, I'm just kidding. Just one of them. Phil and I are at UC Santa Cruz. No, I'm just kidding. It's not the best. It's just
Beautiful
Nice
redwoods
to meet
behind
you.
yeah.
You guys have better Zoom backgrounds than us. I'll give you that, Roger.
Yeah. So Brian and I have known each other for a very long time. We go a long way back to when he was an undergraduate at UC SC. We've been working together.
Exposure complete.
Cool.
Who's you're working with Brian and Laurie and that
Right.
protoclusters?
Yes. I work on protocluster at Redshift 4.57.
Oh my God.
I'm
That's very
trying to
high
figure
redshift.
out. Yeah, I'm trying to figure out how the rate of their star formation is.
I see. This is DMOS survey or a different MOS file?
Yeah, we have a DMOS data, and we're combining that with several photometry and also just VLT data too.
I see. So Laurie and I share a common thesis advisor.
Oh, you do?
In Jim Gunn, yeah.
Oh, wow.
Laurie's I was a postdoc. I think I was on my second postdoc at Princeton when Laurie was a grad student there. So we've known each other for a very long time. And
Wow,
Jim
you
was,
have close ties with
Yeah.
UC Davis.
yeah. And Tony Tyson was my thesis advisor. So that's another close
Oh,
connection.
wow.
Tony was one of my thesis advisors. Jim was the other. And Jim
I
is,
see.
so Laurie and I are siblings, I guess, scientific siblings. Yeah. And that
Good
makes
to
you
know.
my scientific niece.
Yes.
No, that's fantastic. Fantastic. I was going to say so you're 4.7, you said is the redshift?
Yeah, 4.57.
Got it.
So it's like almost 12 billion years ago.
How was it found?
Brian found it through, was it C3VO, Brian?
Yeah, it was. So yeah, Raja, so things have changed a little bit since the UC Santa Cruz days. So we were scratching and clawing back in 15 years ago for one galaxy at redshift 4.57. And we found a few, I remember, in your office.
Yeah.
But so this was discovered with a very large survey with the Very Large Telescope Array in Chile. And so this survey was called the VIMOS Ultra Deep Survey. And this was Olivier Lefebvre who ran it out of Marseille, France.
Sure.
And so we've used those data, and then about maybe 4 or 5 nights of Demos time to compile about 60 galaxies in this cluster, 50, 60 galaxies in this protocluster. And so this is in the Cosmos field.
So this is came out of Z Cosmos then?
No, it's VUDS is the survey, and it's
VUDS,
the
okay.
descendants of Z Cosmos, though we use Z Cosmos data as well. So yeah, so it's a giant amalgam of data from a lot of different telescopes.
We have some very deep, very, very deep Demos spectra in the Candles fields, in the Candles area of Cosmos, Goods North and EGS, and Goods South. In fact, we have 32-hour integrations with Demos on some of these Goods North fields. This is part of something called the Halo 7D survey. Our Cosmos data are not as deep, but we're in the Candles area of Cosmos, and not the. I assume Z Cosmos was a much bigger area.
Yeah, unfortunately, this particular protocluster is not in the Candles area. We could have definitely used the boost that Candles would provide, but unfortunately not. So I think it'll be in this new Cosmos Web program, so that'll be exciting.
Who's leading that?
That's Jehan and Caitlin Casey that are running that.
Gotcha. Yeah, I know them from our EGS collaboration years ago. So this is so Preeti, when I was a grad student with Jim and Tony, my thesis was on Lyman break galaxies. So it was one of the first papers on the Lyman dropout technique, and this was back in 1990. And the highest redshift galaxies known then were redshift 1, and they're really that was there was quasars known with higher redshift, but the highest redshift galaxies were at redshift 1. And this Lyman break dropout is of course for redshift 3 is when it drops out of the U band. So one of my thesis papers was on that, and I was sort of afraid to talk about it because people would think you're crazy. It's like walking around today with the highest redshift galaxies known as redshift 10. And if you told somebody your thesis was on redshift 30, they would sort of look at you funny, right? And this is, but it's, how the times have changed.
You're on the frontier, so.
Well, I was on the frontier, but yeah, the crazy frontier.
Right.
Frontiers of sanity.
But Raja, I remember when I did my undergrad thesis with you, there was maybe like a few tens of galaxies confirmed at the redshift range that we were looking at. So that's like at redshift 4 to 5.5 or so with deep 2.
That's right. And your paper with Marcin was on these high redshift Lyman alpha emitters.
Yeah. So I mean, even to just step back 15 years now, I mean, there was we have more galaxies confirmed in this protocluster than was known in the entirety of astronomy 15 years ago.
That's true. That's amazing.
I didn't realize things have changed this much.
Things have changed a lot.
And with the same instrument too. That's kind of the funny part. Same telescope.
So the galaxy that you were working on was also discovered with Keck?
Yes.
Or were you getting data? Okay.
For Brian's Celia thesis, it all came from the Deep 2 survey. So they were, it was data in 4 fields. EGS was one of them. This was pre-Candles. Same people, but pre-Candles. It was Sandy and David, Sandy Faber, David Krul. And it was EGS. What were the 4 deep fields? EGS, and then, the other 3 fields were not any of these magnet fields. They were, no. This came from the Deep 2 survey was, the PI was Mark Davis, and the other faculty on it was Sandy Faber, David Kuhn, myself, and of course, I felt like a graduate student next to those faculty for reasons that are perhaps obvious, but yeah, so it was as daunting for me as it was for everyone else on that project. So it was fun though. I hope you guys do this with your telescope time, really. And today you're not seeing that many students, but you will in December. December, we really have a December 2nd and 3rd, we have quite a lineup. I don't know if I mentioned this. So Mexico, 6 countries in Africa, Kosovo, and Turkey, all in 2 nights. There'll be groups from all those places. So
That's awesome.
And I'm under no misconception about which way information flows, right? So we're learning as much from the folks who connect with us as perhaps we're learning more from the folks who connect with us than they're learning from us. So it's been absolutely amazing. Even to hear about just the struggles people are going through to take advantage of these opportunities is humbling. It's been absolutely amazing. I mean, I'll give you an example. We were on the Keck telescope in April this year, and we're using ESI, and we had a group of indigenous elders who are astronomy teachers, and they're starting an indigenous astronomy school, the Comcac. They're from the Comcac Nation in Sonora, Mexico, and they were so dedicated to this that they had lost power in their town. So in the middle of the night, they went over to a neighboring town, went over to friends' houses, and they connected on Zoom from there. They were so determined to take part. And what we learned from them is just amazing. Their stories and what they're facing in terms of just in terms of their lives, just in terms of access to fresh water, access to electricity. Some things we're used to taking for granted. It's been amazing. So, yeah, I really hope you guys do this. And I mean, just like you're connecting on our observing nights, I'd be happy to do the same and help in any way we can. One thing we clearly have access to, thanks to my wonderful collaborators, Brian is on this call, my wonderful other collaborators who are not on the call today, but Sam was on the call earlier. We have access to huge networks of students and educators who already have tasted some of this and understand that this is something that's a special opportunity. I mean, Amalia, that's how you connected, is through Ohana Kilohoku. So I think that connection through Ohana Kilohoku, through Knowledge Chikundi and Africa, there's so much trust in these individuals and in these organizations that when they advertise something, kids and educators come in hordes because they know it's going to be good. And it's not their trust in us, but it's in their trust in our collaborators, my knowledge, and Ohana Kilohoku, for example. So you would have access directly to those
exposure complete.
I'm going to keep quiet while we see what's going on here. Is that the second last of the 5?
That's right. So we've just started integration on the last 5-minute exposure.
Got it.
So Raja, thank you very much for that offer. And I think we will plan to do it. So I asked Preeti to come tonight so that we could get a feel for how things work. And I'm hoping we're going to, so I'll email Sam after this and see if we can get something going. We're on the first half on December 30th. So hopefully there's still space to advertise for that. And then we'll be on Subaru and Keck quite a bit starting in the beginning of January, like all up until like the 15th. So I'm hoping to run at least a couple sessions then, and then we'll be talking with Gemini
It's wonderful.
Perhaps Monica can join us in those conversations. Already, as I mentioned to you, the leadership at Gemini is very interested in doing this. So
it's really good to hear. You know, this dovetails nicely because our nights are 2nd, 3rd, and 6th, and then I don't have any time we don't have any time the rest of December, and we don't have any time in January. So that'd be great. That'd be great. Happy to chime in, help.
I'm just a little bit worried about backup plans because our pictures are not quite as nice as yours, Rajas.
You should use this image. I'll send you the link. Just use this image. I mean, it's CFHT megacam imaging of the Virgo cluster. I mean, you know, you can, I'm sure you don't need to use that. You could go to the Hubble Heritage Gallery and, you know, just talk about just having a backup plan is always
yeah, we'd have to use Redshift 0 clusters to talk about descendants rather than
yeah. I mean, and so what I was showing you is the Virgo cluster, so that would be perfect actually for your science, because you're showing a low redshift analog. I have to ask this: how are Laurie's dogs?
Good, for the most part. Her pit mix is having some problems right now, so the last couple months have been a little bit hard. I think they're managing through it, but yeah, she is very dedicated to her dogs, and I think they're living a very happy life. So she has one from, I don't know the last time you met her dogs, but she has Fitz, which is a pit mix that she's had for probably about 10 years now. And then Luna, who's I don't know what breed, but from Puerto Rico. Preeti, do you know what breed? Have you met Luna before? Okay, Luna's a crazy dog.
Yeah, just on Zoom, but not in person.
Small, wiry dog, but really, really excitable and living a good life.
I've met one of her dogs in her office during my last Davis visit, I believe, if I'm not mistaken.
She had a lot of guest dogs, so she did a lot of fostering and looking for people in the department to take dogs on. So she had a constant stream of dogs going through her office, and then they just moved to other offices as people adopted them.
Aw. How and Tony's doing well, Tyson?
Yeah, as far as I can tell, yeah, he's still working and still involved in the department and everything.
So we're about to, in a minute or so, we'll finish this exposure and we have to go to a new cluster.
So for the next cluster, I like 1698 because same reason, it has a close guide star. Highlighted it for the OA.
I see. And the guide star is row 32, index 32?
Correct.
Okay.
I want to grab a few short exposures after this one.
Hey, is there a new star list for me to upload to the AO app tool?
I thought I heard Percy mention something about it.
Yeah, I think Percy found some formatting errors that someone fixed.
Okay. Okay. Got that new star list loaded. Yeah.
Did you put it in here?
Yeah.
Exposure complete.
Okay, so I'm going to change to a 6-second exposure, 1 coad, and do a 3-point dither just to grab some images here. It shouldn't take too long.
Phil, did you say 6-second exposure?
Yes.
Okay. In the H band?
Yes. And there'll be 3 of these.
Exposure complete.
Oh, this is for the same cluster just to prevent saturation?
That's right. I just want to make sure that we have good measurement of the brightness of that center star.
Got it. Okay. And so the counts of the center should now be around 3,000 or 4,000 at most. It was 20,000 before. Right?
Exposure complete.
Yeah, I'm wondering whether I've got fooled by the coads. Because this is, I put it down to 1 coad and now the peak brightness is like 300.
Ah, so we may have been okay before.
I think so.
Because what matters then is the per coad count.
Yes.
Or per image count before the coad. Okay. So
Yeah,
we
have to divide by 5.
Five.
So at 20,000, we were still at 4,000 per.
Yeah,
image.
or 5,000. Yeah, yeah. Or 4,000. Yeah, right. So that should be well below. Okay. Well, this would be a good test, right? We should be able to scale these up by a factor or whatever, subtract it from the others, and if there's no saturation, they should subtract beautifully.
It still looks odd to me that for these short exposures, it looks almost like a point source. And then for those brighter ones, you can definitely see how extended it is. But I think maybe I'm just being fooled by.
Might be a stretch thing, right? I wonder if we
Yeah.
really burn out the center, we might be able to see the same.
Right. Well, I was quick to grab those images. So let's see, we should be on.
So Pran, the number of clusters we'll target, since we have a half night and we're spending about an hour per cluster, we'll target about 5 clusters tonight, star clusters tonight, roughly that. And then your other question about once we finish taking the images, Phil is the expert on this. And so he's, we took half a night's worth of data on the 22nd of August. And we have a half a night of data from tonight. It probably would make sense for him to analyze all of those together. And we use, but we use some technique called point spread function fitting.
Okay. Hey guys, are you done taking images? Are we ready to move?
Yes. So we're ready to move to 1698. Should be highlighted on your screen if I did it right.
Yep, I see it. Just wasn't sure. We're moving there now. And if you need to rotate, you can rotate now while we're still.
So did Percy's fix allow you to calculate the offset correctly now? Without me?
Yes. Yeah.
Right. Was very worried I had a minus sign wrong or RA converted to DAC.
In fact, this one doesn't have much of an array offset. It's 0.08 seconds, so which is very small. That's what is 0.08 seconds? It is, it's about 1/10 of an arc second. 0.08 multiplied by 15. It's about 0.1 or 0.12 arc seconds in RA, but the deck offset is bigger. It's looks like the deck offset is 13 arc seconds.
Yeah.
So Malia, do you teach all subjects to your students or?
I do. I teach all subjects.
Got it. Got it.
Okay, loops are closed on the tip-tilt star. Do you want to take an image here?
Yes. Here we go. Best image.
I'm super impressed by how fast the AO loop closes. Monica, I remember we were discussing, Monica, Phil, we were discussing how much overhead we should plan, and it's really quick.
Yeah.
Exposure complete.
I may have to step away for a bit to get some dinner.
ATS is not settled.
But Monica, we can do the same thing. Please call if you need me to hop back on.
Raja, I think I'm also going to sign up to get some dinner. So thank you very much for showing me this, and I'll be in contact with you about future events.
And thank you. And really, this Heising-Simons' interest in this is very gratifying to me. The fact that there's a literally on the timescale of a couple of weeks, we'll have greater clarity about what kind of funding we expect from them.
Yeah, that's great.
So this is going to happen.
Okay, good luck, everybody. Clear skies. See you in the office bright and early tomorrow, Monica. Aloha.
It'll either be bright or it'll be early.
Bye, guys.
Bye.
These are brighter than the previous clusters. It looks like I have two something or another's I'm looking at, trying to figure out what to do with it.
They could be two separate clusters, or they could be one bright star in a cluster.
I think one thing I want to do is not go to too long an exposure, because already with 6 seconds, I'm at a peak of about 2,500. Yeah, 2,500 in each.
So we can afford to go 4 times longer.
Yeah.
Or 3 times. So if we did 20 seconds, you think?
20 is fine.
And then coads of, I think 10 coads. What would that do? That would be 20 times 10, 200 seconds. That should be fine, right? That should be 200 seconds is a little over 3
Well, if
minutes.
we did 15 coads, then we would be the same.
Sure, let's do that.
Are you taking like for the science? Because we did not offset to the science target yet.
Oh, okay.
That explains it. All right.
That explains.
Yeah. So you're done taking. So do you want me to offset now?
Yes, please offset.
Okay. So when we go to the tilt star and you take a test image, just let me know when you're done so I can offset. To the
Yeah, thank
science
you.
target.
That was my misunderstanding that we were.
Yeah, no worries.
Okay, so yep, please go to the science object and let me know when it's okay to take an image.
Okay. Yep,
Sure.
we offset to the science target. So, and loops are closed.
Okay, taking a test image.
So Phil, this must be, instead of having one bright guide star, we just happen to have 2 bright stars next to each other. It looks like, because the PSFs look identical between the two, so this is reassuring. I mean,
Yes.
I'm seeing all the little bumps and wiggles on the PSF are repeated from one star to the next.
Exposure complete.
This must be the image of the new cluster.
It is, but
Are we zoomed in? I'm not seeing anything. I want to check FactSum.
I'm going to take a longer exposure.
Okay. Just going to check one thing really quickly here. The offset is in the correct direction. It's offset north from the guide star. So that's how it should be. That's what, you see on the FactSum, it says plus 12.91. So it's a positive offset. That's what it should be according to the coordinates. This is star cluster 1698, I assume. Yeah, offset's in the right direction. So it must be a faint cluster, which is better actually for AO imaging, right? I mean, because if it's one star blasting the rest, it's very hard to get photometry. So So this could be a better star cluster. Hi, Arya. How are you? You're back. Good to have you back. Arya, you have to apply to the SIP program this summer, this coming summer. We've been Heather and Milani have been talking to me about getting you involved in SIP. You would apply. It's an online application, opens at the beginning of March. Just one moment, sorry.
Exposure complete.
So Arya, there's a couple of things. We're going to run a Python tutorial probably in January, February. We'll let you know about that. But we'll definitely have you apply to SIP. And if you like, come out to Santa Cruz for part of the summer. But if not, if you can't do that, you can do astronomy research from right where you are. Monica and I have been mentors before. Avi has been a mentor before. We're going to rope Phil into being a SIP mentor next summer, I'm sure.
It'll be fun.
Yeah, no, he's
Tony, could we go back to the guide star?
Sure.
Hi, Amalia. Thanks.
Concerned that we don't understand what we're seeing here.
Do we also want to double check that we have the right one? I mean, I think we do.
Okay, we're back to the guide star.
Thank you. Taking a test image.
Phil, you said test doesn't get saved.
Correct.
So, okay, 1.5 second image.
Exposure complete.
There we go. Nothing wrong. They're there.
Yeah, and if we were locked on the left star compared to the right star, it really wouldn't
matter.
Make too much of a difference.
Exactly. We would still see. We would still be there. So I don't know what's going on. And the offset. Yeah. Sorry.
Well, I'm just looking at the guide star tool, and you know it does show exactly the guide star is pretty much due south of the science object by about 12 arc seconds. So I mean, it's putting in the right offset.
Maybe it's a faint cluster, really faint. So.
Well, there were some objects there. They weren't very near the center of the screen. So I wonder how.
Yeah.
And just to confirm, kind of on our end, we're seeing that there's, another star a little bit to the south of our double star. We're pretty sure we're locked in on the right one because it has the correct magnitude. But are you seeing kind of the same thing? Like, are you agreeing that with your finding chart, looks like we're locked in on the right one?
I think so. I mean, the next star on the finder chart is another like 10 arc seconds down. So I doubt we're off by that much.
Yeah, most would be off by an arc second or two. Wow.
Well,
I mean, do you want us to try locking in on? Because I think we're right now grabbing the top one of the two, right? I don't know if you want us to try the other one, but as you said, I don't think that would make a huge difference. I mean, you can see how separated they are.
Yeah, it wouldn't make a difference which one you locked onto because the star cluster should still be well within the frame.
Mm-hmm.
So I'm looking at the magic guider and I see two stars, but is one of those just a reflection?
Yeah, we have the ghosts on the left side, and then the right is what we're locked in on.
Okay. And then you're seeing that fainter pair to the right of the brighter pair.
Slightly to the upper right of the brighter pair. Those are ghosts, I believe.
Yeah.
Yeah, that must be the one you're referring to. That's about 10 arc seconds off.
No, we don't mean that, but what Phil is saying, there's a pair of bright points, and then to the right of that, there's a pair of faint points.
Yeah.
Yeah.
The faint points are ghosts.
So, no, the faint points is a different star off to the right. So we have the star in the reflection immediately to the left of it, and then on the right there's another star with its reflection, and that's the two faint guys you see.
But we're seeing two stars on our NIRC2 image, not on the guider. We're seeing two stars on the NIRC2 image. How come we're seeing one on the guider? Is it a different star on the guider?
We can see two on the guider. They're just, they might look just a little.
Maybe there is no ghost image for this one.
No, that's a ghost image. And then a little bit on the bottom, we can see the companion on the guider. It might just look elongated on your side, depending on what kind of cut you're using.
Yeah.
But we can see the two stars in the guider.
Okay. And they're offset vertically from each other?
Yes.
I see. And Phil, that's what shows up as, because here north is, I mean, one is east of the other, and that's how it shows up on the NIRC2 image. Right?
Yes.
In the NIRC2 image, east-west is running horizontally.
If you look at the rows on their screens.
Yeah, exactly. Exactly. That makes sense. I get it.
Yeah, so I mean, I think we're pointed where we expect to be.
So I think we offset to the star cluster. Let's
Yeah.
let's take
That makes sense now.
let's take a long exposure on that. What do you think, Monica? Do you have any objection to that?
No, I think it's fine, Roger. Let's go with what you have in mind.
Yeah, let's just offset to the star cluster. Let's do a sequence of long exposures like we did before. Phil, you were doing, what is it, 5 minutes times 5? Go.
Okay.
Yes.
Do you want me to offset to the target now?
Yes, please. Right, Phil?
Okay.
Yes, go ahead.
Okay.
Okay. Offset is complete and loops are closed.
Okay. We're going to take one more test exposure and just make sure we understand what we're looking at.
Okay.
Okay.
And the test exposure this time will be 60 seconds?
Correct.
Okay. Hope there's something there. Vasant, we haven't had a chance to hear from you. How did you hear about us? Oh, thanks. Which talk? From the Sacramento Valley? Oh, okay. Thanks. No problem. No problem, of course.
When was that talk, Raja?
I'm trying to remember. It must have been last month. It was virtual. I didn't go out to Sacramento, but I had planned on going out, but because of the pandemic. Yeah, about 6 weeks ago, right? Okay. Life has become such a blur now that I don't
Exposure
remember.
complete.
All right, moment of truth. Do we see something? Whoa, nothing. Absolutely nothing. What about changing? Yeah, let's see if changing the stretch does something. I mean, there are stars, but nothing at the center, nothing anywhere near the center.
Yeah, the only thing that looks like a cluster is that thing way off to the upper right.
Yeah. I have no idea what's going on here. I'm hesitant to waste an hour on this.
Yeah, there's no reason we need to choose this cluster given the problems. Let me look at what my next pick would be, unless Monica has a favorite.
So we have been trying to cross match and with Avi's list, and apparently he has a pretty limited number, so nothing matched up with what Savnik has.
Okay.
I'm having my fingers crossed that what the list includes only clusters and the list is pure. That's what I'm hoping. So Phil, when we take a next exposure, is it possible that we put a break in the first, after the first, maybe to see what's going on?
Sorry, I didn't catch that suggestion.
Yeah, instead of taking 5 frames, like can we, for the first shot, like we just take 1 frame and just confirm that the cluster.
That's what we've done here, Monica. We've taken a single 1-minute exposure to see if we see anything.
Okay, so,
Yeah.
so like the 5 or 1 hour that we haven't really spent on it. I got distracted.
Yeah, this is just a 1-minute exposure. We haven't gone into the full sequence because it's not worth it for this one. There's nothing there. If we don't see anything in 1 minute, we're not going to see anything in 5.
Okay, awesome. Thank you.
Arya, I've just sent you the link to the program, and it's called the Science Internship Program. It's a summer thing.
Okay, I think I'm going to go on to 599, basically
All right.
the next one down. If
I'm going to step away and I'm going to come back in and check. But Monica, you have my cell phone if anything comes up, but I won't be far. I'll just.
Tony, I think I've highlighted the next science object I want us to go to, 599.
Oh, okay. Just going there. So we're using the same guide stars then? Looks like.
Looks like it's based on
Well, that's interesting. It is the same guide star.
Yeah, just different offsets. Okay.
Apparently. Yeah, this cluster is due south of the same guide star. All right, well. I think I can see something's there in the finder charts.
Okay, loops are closed. Do you want to take a test image?
Okay, taking a test image.
Which do you want to offset?
And after the image is done, do you want to offset right away?
Yes.
Exposure complete.
StS is not settled.
Okay, I'm going to offset.
Yeah, go ahead. Not surprising, this looks like the same guide star we were looking at.
And this is the correct rotation angle, right?
Yes.
Okay. Okay, we're offset and loops are closed.
Thank you. Taking a test image.
So I missed that.
Exposure complete.
Is the node horizontal to the left in this image that we're seeing on the screen?
For the NIRC2 image, north is straight up. But I'm confused what's going on here. So we offset.
Okay. If we still aren't sure we're seeing anything, I can check pointing and re-acquire the star too, just to double check that we're pointing correctly.
This is 599. That's right, 599.
Yeah, the science object is 599.
This is a legitimate cluster. I can even see it in optical images. Pretty bright.
Yeah, I think we're seeing it on the guide camera. I think it's straight to the right of the guide star we're using. So to me, it looks like the NIRC2 image, like the loops weren't closed. Like it's a very diffuse looking structure. Let's try a slightly longer exposure. I think I trust that we're pointing at the right object because the guider looks like the finder chart. Two objects, one to the north, one to the south, both bright enough that we should be able to see them.
Exposure complete.
Ah, there we go.
Nice.
Looks better. Okay, that is a beautiful looking cluster. It's just diffuse. Like there's a lot of faint sources, not one big cluster, a star at the center of the cluster. All right, so I think we should just take images here. You agree, Monica?
Yeah.
Yeah, it's exactly what we expected to see. Okay, so coads 5. So we're going to take 25 minutes worth of data here. And maybe I should go for like a 1 arc-second dither because it looks pretty big.
Yes. Yeah. I mean, like the typical sizes that Roger mentioned, that was like 1 arc-second. this might be, yeah, I mean, let's try out with 1 arcsecond for the data.
Okay. Yeah, there's something I don't understand about this number I put it. 'Cause when I put 2, it actually seemed to do like a 4 arcsecond.
Is there
And-
been like applied somehow in this script?
Yeah, I don't know. Oh, you know, I wonder whether it's taking the nod, multiplies by the nod north and east. And so that would make sense why I was doing a 1 arcsecond or a 4 arcsecond. Did there. Anyways, I think I'm going to go with 1. Well, which will actually be a 2 by 2 arcsecond data, which should be about it.
Exposure complete.
Avi, are you there?
Yeah.
Take a look at that image.
Yeah.
And the box that you're seeing. And then you're struggling to difference. So you're trying to figure out one of those stars being variable or not, right? So cool.
Definitely.
So, I mean, ideally, we would have liked to squeezed in, you know, like one of your clusters, your variable star host, but yeah, it's a bit unfortunate that your threshold was a bit too high and you missed that.
Yeah, I apologize. I haven't
No worries.
I should have been more prepared for this.
I mean, I think it's my fault as well. I sort of like sent the last minute to you. But I think this is good exposure for you so that when you have the final list, we can request for the next campaign as well. And this is the only way that we can retrieve the period for our star.
Right.
Exposure complete.
Create some worse seeing in that image. Doesn't look nearly as good quality. I'm gonna grab a coffee. I'll be right back.
Yeah, sure.
Yeah, a few more minutes.
Avi?
Yeah.
So you're reading in the file, right, on Data Lab right now? Is it being done automatically?
Yeah, I just realized what I was doing was not the correct. It's cross matching with the FAT data set, which is not. You just want the RA index from that file. That's, you don't want anything else. That's what I'm right. That's what I'm
Yeah, it's just the area deck for the 2,700 stars.
Exposure complete.
I have a question for Tony and Arena. Took some initial images on this object and they look quite good, and it seems to be degrading. I don't know if it's because the seeing is getting worse, or is there a way from the AO system that can tell us the residuals or anything like that?
ACS is not settled.
Just check the artifacts. What did it take?
Okay, yeah, I can check the R0 meter.
Where does the R0
Just-
come from?
It's the post-AO correction measurement of the seeing.
From the wavefront sensor?
Yes.
Okay.
But just, looking at things on our end, I don't see anything wrong necessarily. We do have some clouds coming in, but I don't think they're quite, they're not to us yet, they're mostly in the south.
Yeah, so the R meter's scene estimate is about 0.7 arc seconds.
It's not the best, but it's not terrible. I really don't see much on our end. I could be wrong.
Okay, yeah, just curious what I was looking on the NGS AO status for something like that, and I didn't see where the R0 is reported. Is that something that I have access to, or is it just in the operator GUI?
I'm not sure. I pulled it up from the Maori GUI.
Yeah, that's on our end. That might be a question for Percy, but honestly, I don't think that's something we can directly them, but
okay.
I'm not 100% sure.
Yeah, for the Sacrament, we don't have a lot of information like what you would like to get. I think the closest one that we have is, you get the image of a star. I mean, there is a way to calculate the strail from that, but that's the closest we can do to get like a wavefront error.
Okay, yeah, I was just curious what's available.
Exposure complete.
Yeah, okay.
Exposure complete.
Well, I think I'm going to switch to K-band. I'm a little nervous that these last few images have all looked poorer quality. I'm looking at the CFHT seeing monitor, and it's up around 1 arc second. So I may have just hit a patch of bad seeing, but first image or two of this cluster was really beautiful, and then these last few almost look like I'm not sure they're usable. It doesn't look like clouds because it looks like the wavefront sensor counts have stayed pretty constant. All right, well, here we go. Taking some more data. K-band. Oh. We had a new visitor. Hi, Austin. Wasn't paying attention to the chat.
Gemini said that in the last 20 minutes, they saw scene jump up quite a bit, so that's probably what's going on, unfortunately.
Okay, yeah, I think that's consistent with what we're seeing.
Hopefully it'll get back down.
Exposure complete. Exposure complete. Exposure complete.
So I'm trying to decide what the next step is, Monica. I suppose we could go deeper on this cluster since it looks particularly rich, or move on to another one. I could just keep going down the list of things that I think are make good targets, but if you had a suggestion, let me know.
Phil, I think it would be nice to go down the list and then have maybe a third target before we go deeper on this. Yeah.
All right.
And, yeah, I unfortunately we've not been able to find a match that we've been looking for in this 27 clusters.
Okay.
Yeah, I mean, it's
Monica, I just sent a message in the chat. I was able to find one. It's I think it's the 14th line in the AO.
you have to
In that text.
do you have the cluster ID? It's the second column, if I'm not wrong. No, sorry, the first column.
You said second column, or
Which file are you looking at?
the one sent at the beginning.
Okay. So can you read off what is there in the first column then?
It says I think 13, then 3983. Is that?
Can you please copy the line on in the chat?
3983 is a cluster ID. That's line 13. So that's.
Yeah. So if we could squeeze that in.
Oh.
Yeah, 398.
Yeah, that looks like a perfectly doable one.
Awesome.
Let's do that next.
Yeah.
Hopefully it's bright enough.
Avi, what was the sigma?
Exposure complete.
The threshold that I set for the detection.
For this cluster? Well, I mean, forget about the sigma, but if you check the difference image, did you see a clear source?
Yeah, let me pull up the PDF file.
Yeah, sure.
So the only weird thing about 3983 is that the DSS image looks odd.
I clicked on the SDSS. I'm not sure if SDSS is there, but it seems that there's a blob of light, at least in the SDSS frame.
Okay. Well, it's worth a try, because I mean, I think I trust Sajnik's photometry from the HST more than anything.
Okay.
But we may have trouble.
Exposure complete.
Was that your last exposure? Yeah. You're muted if you're trying to talk.
Sorry, I was talking to you, and anyway, we're ready to move to our next science target. It's 3983. Should be highlighted for you.
Okay. It's going there now.
Oh, looks like focus was zero now.
Cluster looks quite nice in K. A lot of sources. That guider image is encouraging, so I bet that's our cluster off to the west of the guide star.
Okay, loops are closed.
This is the guide star we're on, right?
Yes, the guide star. Do you want to take an image?
Yes, I will right now.
Exposure complete.
Okay, yep, I can see the guide star. Could we offset the science target now?
Okay, offsetting. Okay, offset's complete, loops are closed.
Okay, taking a test image.
I'm back, you guys. Sorry for the long delay, but
Oh, you missed our
what happened? What did I miss?
interesting cluster.
Exposure complete.
Interesting in a good way?
Yeah, well, just more diffuse, so you could see the stars a lot easier, more easily.
Gotcha. Not this one, right? Not the one.
Not
that's
this one.
I see. And Arya, to answer your question, it's going to be hybrid next summer. That is, you'll have the option of attending online or in person or a combination of the two. That is online for part of the summer and in person for part of the summer, if you'd like.
Okay, I'm convinced this is our cluster. I'm hoping that was just a bad image.
This looks quite diffuse, Phil, right? So this is similar to the last one.
Yeah, it doesn't look like very good correction at the moment, but that might just be momentary. We've been having good seeing and then bouts of sort of mediocre seeing, maybe even bad.
I see. So this is an AO corrected image, this one?
It is.
Okay.
But to me, it looks like it's when we were on the guide star just a moment ago, it wasn't looking very good, and this one is similar.
I see. So it's not just this. Okay.
I'm just going to go ahead and take the data.
Okay.
I've noticed some frames turn out good, some don't. I think that's for these conditions best you can do.
Best we can do. Okay, I'm going to actually stop the Zoom call and the share, but Phil, I don't know if you're able to screen share on your VNC on Zooms just for the benefit of those who are connected. And I'll, in about half an hour, I'm going back home and I'll be able to connect and continue. Okay. That'd be great. Thank you.
Raya, sorry, could you make me host?
I will do that, of course. Thanks. Sorry.
So I want to do TNT 60 and coed 5. See how we do.
Percy, you should be host now.
Thank you.
Thanks. I will sign out, and Monica, same thing. If you call me, please, if anything comes up, I'll be on the just driving home.
Yeah, we'll do that.
Thank you. Good luck. I'll see you guys later. I see a lot of new names on the list, so I haven't had a chance to say hello to everyone, but I will later. Take care.
See whether I can share my screen.